Our topic for today is on combinational logic circuit, and on this topic, we are expected to be able to convert a logical expression into a sum of products, use Boolean algebra and the Karnaugh map as a tool to simplify and design logic circuits, and explain the operation of both the exclusive or the exclusive NOR circuits. So under this topic, we'll be discussing about the canonical forms, the POS and the SOP, simplifying the logic circuit using algebraic simplification, simplifying logic circuit through Karnaugh mapping, the exclusive OR and the exclusive NOR, and the parity generator and checker. So first, let's go to the canonical form. So we have the SOP. So in SOP, we have two or more terms or products that are ORed together. So as the name implies, it is the sum of products. When we say sum in logic, that corresponds to OR or the ORed function. ORed function ra ay sum of products. The product is ANDed. So if you will notice in this example, the A bar and the B bar, this is a product. The A, B, and C is also a product, and these two terms are added or summed up. So that is why it is called the sum of products. We have a product, and the two terms are summed. The other one is the product of sums. So in this example, so in this form, the two or more OR terms or sums are ANDed together. When we say two or more terms uh, are summed, two or more sum terms are ANDed together. So in this example, we have the A plus B, that is a sum. Then it is multiplied to the quantity also A plus B plus C. The parentheses here of the two terms, this is term number one and this is term number two. The parentheses in the two terms indicate a product. So that is why it is called the product of sums. So let's now go to converting SOP expression into a truth table. So if you will notice in this example sa ating SOP, when we say sum of products, please take note that in this truth table example, the output one are considered in the conversion of SOP expression into its corresponding truth table. So let's redo, or how did we arrive at this kind of truth table? So, so as we have mentioned, or as mentioned in the example, when we say SOP, when we say SOP, we consider outputs with one na value. So in the first example, we are asked to develop a truth table truth table for the expression okay, na, A bar B bar C plus A B bar C bar plus A B C. So we are asked to develop a truth table for the expression A bar plus A bar times B bar times C plus A B bar C bar plus A B and C. So in developing a truth table, so first we will consider how many outputs do we have or how many inputs do we have. So in the given example, we have three inputs. We have input A, B, and input C. Then this will be our output. So since we have three inputs, how many combinations or how many inputs combinations do we have? So that is 2 raised to 3. That will give us 8 inputs. And what are these inputs? That will be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So these are the 8 inputs kang aton nga truth table. So as we have mentioned, in developing an SOP truth table, we are considering the outputs with 1. So, diin da karang nga combination ang maka-output kang 1. In which combination will it give an output of 1? So, as discussed when we say bar, in an input means it is 0. So, if we will interpret this input into its binary equivalent, this is 0, 0, 1, this is 1, 0, 0, and this is 1, 1, 1. Therefore, the these inputs combinations above will give the output of 1 because, as we have mentioned, we are to develop a truth table using the SOP, and SOP will consider the output nga 1. So, din kita mag-output ng 1 here in 0, 0, 1, 0, 0, 1. It will have an output of 1. 1, 0, 0, 1, 0, 0. It will have an output of 1. And lastly, 1, 1, 1. And all of the rest combinations will have the output of 0. So this is the truth table for this expression or for this combination. So we'll try to check with the example. So that is the one. So that is how we develop this truth table in the given example. Next, converting POS expression to the truth table. So here in our second example, we are asked to develop a truth table for the following inputs combinations: 0, 0, A plus B plus C times A plus B complement plus C and A plus B complement plus C complement plus A times A complement plus B plus C complement times A complement plus B complement plus C. Now, before we proceed to reconstructing this truth table, so I wanted you to take a look at how our POS expression is written. So take note here that in the POS, those with zero inputs are written in true form. Zero inputs are written in true form, and those one are written in complemented form. So here, if you will notice, 0, 0, 0 is written as A plus B plus Z. This is true form. And here, in the second expression, you will notice that 0, 1, 0, the A is in true form, the B is written in complemented form because it is 1, and the C is also written in true form because it is 0. In the third expression, or in the third term, we have A plus B complement plus C complement. If you will notice in the inputs, A is 0, so it is written in true form A. B is 1, so that's why it is written in B complement, and C is written in is 1, and it is written in C complement. So that is how we write the expression in the product of sums. So let's reconstruct the uh, truth table. So if you will be the one to draw the truth table for the given expression, so product of sum. So here we are considering the output with 0 as indicated in our example. So going back, so POS, so derive a truth table for the expression. What was the example? A plus B plus C. I think sobra siya. Let me rewrite it below. Yeah, quantity A plus B plus C times A plus B complement plus C times A plus B complement plus C complement plus times, sorry, complement plus B plus C complement times A complement plus B complement plus C. So with this example, again, we have three inputs. So we will draw three inputs. This is input A, this is input B, and this is input C, and this is the output. So what are our input combinations? Again, we have 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, and 1, 1, 1. So we have 1, 2, 3, 4, 5, 6. Ay, kulang. I forgot. Just let me add here. I forgot 0, 0, 0. the combinations 0, 0, 0. This is A, B, C, and this one will be our output. So as I have mentioned earlier, in the POS, those in zeros or the input in zeros are written in true form, and those inputs in ones are written in complement form, and we are considering the outputs will with zero for this truth table. So here, ABC, this is 0, 0, 0, because as we have said, 0 is written in its true form and 1 is written in its complement form. So this one is 0, 1, 0. This is 0, this 1, 1, and this is 1, 0, 1, and this is 1, 1, 0. So we will have a 0 output since we will be considering the 0 output on this combination. So 0 in 0, 0, 0. So 0 in 0, 0, 0. 0 in 0, 1, 0. Where is 0, 1, 0? So it is 0 here. Then we have 0 in 0, 1, 1. Where is 0, 1, 1? Here. It is also 0. 0 in 1, 0, 1. So 0 in 1, 0, 1. So this is 0. And another 0 in 1, 1, 0. This is 0. The rest of the combinations will be 1. So that is how we write our POS expression or POS expression into truth table. So I hope it is clear on how to write or how to convert our uh, POS expression into truth table. So the same when you are given a truth table and if you wanted to convert it into an POS expression, just do the same. Just do the reverse. So still you are to consider outputs with only zero output and you are to write uh, those inputs with zero in its true form and those inputs with one in its complemented form. The same in the SOP, as we have discussed. If you are given the table and you are to convert it into an expression, consider only those expressions with output of 1 since it is SOP. And uh, those inputs with 1 should be written in true form and reverse those input in 0 is written in complemented form. That is for the SOP.